Hey everyone, in this video we will see how you can prepare for your data science interviews. If you've never interviewed for a data science role before, or if you've been giving interviews and have been failing to prepare well, this video is for you. In this video we will dive deep into different areas of data science that you can prepare for, what are the topics that are most commonly asked during the interviews, and I hope this video will help you understand and help you improve at your interviews. Well, let's just dive right into the video.
Let's talk about projects, right? Even before we talk about the kind of topics that you will need, if you're not there in the field already, building projects is a way for you to show that you can actually do something. You can actually build data science projects. A lot of the interviewers will ask you about, let's say you talk about building a recommendation engine, right? So how did you go about building it? What were the data sources? Why did you choose that? How did you handle missing values? Or maybe what was the data set balanced? What were the statistical techniques that you had evaluated for building that? Did you even need a statistical technique? So questions like that, right? All these kind of questions will come up uh, in the interview. So if you have done projects, please be prepared completely about them, right? Be prepared to go in depth on the projects that you have worked on, regardless of you being a generalist or a specialist, because that is what is something that you have worked on and you're expected to know that pretty well. If you know the why as well, then it's fantastic. If you know why did you do X over something else, great. So understanding deeply helps you stand out more. If you've worked in a team previously on a project, talk about your role in the project, talk about other people's role as well, and how that helped you improve your role, or how were you coordinating and collaborating with them. Okay, so a little bit on the kind of different topics that you can work on. And as we saw earlier, data science can be broadly defined as data science equal to programming slash hacking plus math slash statistics plus the domain knowledge. And it's a combination of all these three things. So please be prepared to answer questions on each of these subsections. Again, a lot of these questions will vary depending on your background. If you come from a math background, then it's likely that the interview is going to be math heavy. If you come from a programming background, maybe programming heavy. If you come from a domain background, maybe domain heavy. And also the background of the interviewer and the company and the role. So it's a combination of all these things that will lead to the questions that are going to be asked in an interview. But from your side, you have to be prepared on all of these different subsections. So please do that. And though you're not expected to be as good a programmer as a typical programmer is, or as good a statistician or a mathematician as a typical mathematician is, you're supposed to understand what is happening, right? You're supposed to know what is happening and have a basic intuition for everything. Understand the workflows. Like maybe you might not remember all the equations at any given point for a given algorithm, but maybe you understand intuitively how it works. And given time, you can derive the equation or you can write the equations, right? Because you understand it intuitively, you can come to that. So just prepare for it in that way. Now let's look at the different categories we're talking about. Programming or hacking skills that we mentioned already. So you should know how to program. This is, I think, a hard requirement nowadays because a lot of the companies are building digital products, and you won't be able to do anything if you can't program, right? You won't be able to, let's say, even SQL, right? If you can't write SQL, you won't be able to query data. You won't be able to get data out of your database. How are you going to do any analysis, right? So should know how to program. That's a bare minimum. Ideally, right now, because the market and the industry is working a lot in Python and R, these one of these or both of these programming languages is something that you should be concentrating on if you want to be in data. Um, Understanding of computer science fundamentals, data structures, algorithms, space-time, time-space complexity is helpful. It really helps you improve your code. So these things again are not required if you're a total beginner in programming. Don't even have to think about that. Even the third point is understanding of different programming paradigms: object oriented, procedural, imperative, functional. Don't have to worry about all that initially, but as you go further, because more and more code will be written, like for example scikit-learn, right? Scikit-learn is it's a machine learning library in Python, and if you look at their code, they have written in an object oriented way. I mean, it's good to learn this. It's not mandatory, and this is not asked during the interviews. But then if you've given, let's say you're given a take home task, right? If you demonstrate any of these things, if you demonstrate that you know what a function means, you know when to convert multiple lines into a function, or you know how to write a class and define objects and call them and pass parameters, if you can show all of that in the take home task that you're given, great. I think then you can show that, hey, you understand these concepts, you're likely to write clean code when you are hired, and that's a big plus point, right? So yeah, this is on programming knowledge. The ways you will be tested for these in interviews are the ways I was tested. I can think about that. I can tell you about that. Was I was one of the companies gave a hacker rank test. Another is the take home test, which is another format where you are given a data set and a question, and you're asked to find certain inferences, right? So then you're expected to write maybe a Jupyter notebook or a script and give it back. So in one of the interviews, I had to do both. I had to write a Jupyter notebook. I had to show how I would productionize it as well. So I had to write functions, create an API, and give it back. So this was one interview that I faced. Another experience was pair programming. I don't know if you've heard of this, but it's very similar to a whiteboarding kind of. So the other person will be listening to you as you speak out loud and solve the problem. So these are the different kinds of programming problems that you would get while applying for data science jobs. Math knowledge, understanding of the basic concepts in probability, statistics, linear algebra, and calculus. Concepts in probability might include events, random variables, Bayes theorem, conditional probability, joint probability, etc. So I've been asked questions on most of these things, on random variables, Bayes theorem, events, not on joint probability. But yeah, so this is like basic probability that is asked. Concepts in statistics might include measures of central tendency like mean, median, mode, or measures of variance like standard deviation variance, statistical tests that you could use to maybe check correlation between two variables, and depending on the kind of variables, right? If it is a categorical variable or a nominal variable, all these things come into picture. Hypothesis testing is one. Experimentation. How do you do a hypothesis testing? What is yeah, so where does it use? Hypothesis testing is essentially A/B testing used a lot by marketers. So how do you determine the sample size? How do you stop? When do you stop your hypothesis test? What is the metric? What is the z-score? What is the p-value? How do you calculate a p-value and stuff like that? That is basic statistics. And linear algebra, I haven't been asked a lot of linear algebra questions, but I thought it would be good to put here so that you can also revise. Like matrices have different operations, right? Like what is the rank of a matrix, and what are the, yeah, how do you do dimensionality reduction in matrices? So PCA is principal component analysis. This was also asked in one of the interviews where I was asked to explain it mathematically. How does PCA work, right? So things like that. Concepts in calculus might include differentiation. So things like that. So I have put math knowledge and statistical and machine knowledge as separate because this is an entire topic in itself. So math knowledge is more geared towards uh, probability, statistics, algebra, linear algebra, and calculus. So these are like math, right? This is coming from math. And then one branch of statistics is statistical learning or slash machine learning. And this itself is huge. Like math also, you don't need to know everything that exists in probability. You don't need to know everything that exists in statistics, but a lot of the things around Bayes theorem, a lot of the things around mean, median, mode, deviation, variance, hypothesis testing, and stuff like that, right? So this is math knowledge. This is statistical and machine learning knowledge. So what you would need to know in this is understand all the different concepts in statistical learning, like supervised learning, unsupervised learning, reinforcement learning. You should be able to conceptually explain what you mean by supervised learning, the kind of data sets you can work on using supervised learning, the kind of problems you can solve, like for example, classification, regression, the different algorithms that you can use for each of them. I'm not going into the details here about the techniques like linear regression, logistic regression, SVMs, random forest, decision trees, and deep learning neural networks, etc., etc. These are the different techniques you could use for all of these problems. K-means clustering, hierarchical clustering, etc., etc. Those are unsupervised learning techniques. Different, so different. These are different methods, and like there's a framework that I use to think about them, so, which is representation, evaluation, and representation, optimization, and evaluation. So representation is the equation used to represent that particular algorithm. Optimization is the optimization technique that you use to improve the performance of a model, and evaluation is the metric that you use to measure and evaluate the performance of your models. So what are the different optimization techniques? It could be a gradient descent or stochastic gradient descent or any other technique that you use to optimize your algorithms. Evaluation metrics could be your accuracies, your precision, your recall, or your AUC ROC curve that you use, or uh, or your false positive rates or your true positive rates. So these are different kinds of evaluation metrics that you could use to see the performance of your models. And then maybe concepts like cross validation, k-fold cross validation. How can you improve the performance of your model? How can you split your data sets, right? Train, test splits, validation split. What are the different ways in which you can split your data sets? How is your data set collected? What are the different distributions that exist? This is going a little bit back to the math. What normal distribution or a binomial distribution? What kind of events can be modeled using these distributions? And one more thing about, when you split your data set, is it a stratified split or is it a random split? So all these things are important for you to know, for you to be able to tell the interviewer. Maybe things like if there are missing values, what are the techniques that you would use to handle that? If there are outliers, what are the things you would do to handle outliers in your data set? Or if you have a lot of dimensions, right? How can you actually reduce the dimensions without losing a lot of information? Things like that. Or what are the different techniques that you use? What can you do, right? So all these things, I mean, whatever I'm telling here are questions that have been asked to me in one or the other interview. So these things are required. And uh, the biggest thing about data science is that you never know what kind of question you might be asked. uh, Depending, like I said, it's a combination of all of these things, right? It comes from math, computer science, statistical learning, and the backgrounds of the interviewer and your background, all of these, the projects you've done, all of these matter. So just prepare across these topics is what I would say. Going forward, domain knowledge, a lot of questions are not asked on these fronts, but then a few might be asked. Especially if you're just getting started, you're not expected to have a lot of domain knowledge, but then having domain knowledge gives you a clear advantage. So understanding of the domain you're working in, looking to work in, different, and this is different knowledge for different domains like pharma, telecom, education, HR, media, etc. Like I said, each domain has its own trade secrets, so to say. And if you know that, and if you've used that to build a project, right, then, and you're applying, let's say you have some domain knowledge in pharma, and you're applying to a pharmaceutical company and saying that, hey, I know how clinical trials work, I know how to extract patient information from clinical trials using natural language processing, and I've done this was my project. And now this is showing a lot of things here, right? This is showing how you know how clinical trials work, which is again a very domain specific thing. You know how pharmaceutical companies are looking for this kind of knowledge, and you know how NLP techniques work, you know how to extract stuff from that, you know how to use a computer to do that. So you are using the entire set of skills that you have to do that project. And this is the kind of project that would be very useful for a pharmaceutical company, right? But this might not be useful for a media company. You can't go and say a media company that I did something in clinical trials, look at that, unless it is WikiLeaks kind of a thing, which is something that you could also do and then show it to. Yeah, like for example, if you go to WikiLeaks data set, it's huge, right? You can go out and find some relationship between those things, and go to a media house, and they'll hire you. So that's about domain knowledge. Broad understanding of the use cases where data can be applied to solve domain problems is very useful. And typically not a lot of questions are asked on domain knowledge. A lot of the questions are on, like I said, how, if you can program, if you can understand math, if you can understand the different techniques to work with data. This is an added advantage every time if you know the domain really well.
Thank you so much for watching. If you really like this video, please do give it a thumbs up and don't forget to subscribe to the channel.